My name is Tamir Khan.
My name is Kate Petrowski.
For senior design, we worked with State Street Global Advisors in Stanford to compute correlations using the R programming language. So a summary of the work that we did, we received a large amount of financial data from State Street. We were tasked with finding correlations and other relationships between these different data sets. We also provided visualization and verification of our results.
This is an overview of our processes throughout this project. We learned R, we were given various data from analysts. We found patterns to correlate, we created visualization tools, and we verified our results with analysts and created handoff documentation.
Here's an example of us cleaning data that we received from State Street. We started off with large data sets that looked like this, that were a little messy. We extracted irrelevant information, and then we combined based on certain criteria.
Now here's an example of the extraction of information. Here we have a data frame with ticker and our correlations, and this is an example of an output that we presented to analysts.
And other than also speaking with analysts, we were able to provide visualization which helps us verify our results. For example, the price movement of Walmart has a pretty high correlation with the ESG score movement of Walmart. And here we were able to graph these two, and as you can see, they have pretty similar graph movements.
Throughout this project, we learned a lot about documentation and coding standards required within industry, and we were able to create a model that will be handed off to State Street and utilized within their firm.
SSGA analysts working from the UConn Stanford team. My name is Sully.
My name is Augusty.
And we worked on the Python model computing correlations, specifically in the cloud environment. To give a top-level summary of our project, we worked specifically on information processing through the aforementioned Python model, as well as corroborating it through the R model offered by Tamir and Kate. We set it up in a cloud environment, working with an x86 architecture virtual machine that had an Intel CPU platform that was hosted in the Google's Cloud Suite. And we had a host of documentation available on GitHub with an architecture diagram and a data dictionary that you can check out.
Okay, so on the left, we have an example of the cloud database tables that we've loaded into the MySQL database. What we've done is we've built a loader to load the millions of records into MySQL databases from the compute engine. And then on the right, we have an architecture diagram of how this works. So we have the loaders loading the records in. And then once the server is populated with the records, we then use our correlation model to not only pull these records from the cloud database, but to also then calculate correlations off of this. And at the top, as you can see, this is my directory. This is where we kept all of the correlation models and files. The bottom left shows an example of the Python correlation model output, which is a text file of all the correlations for all 500 plus stocks. And on the right, we have a data dictionary of the column names for the records, for the column names in the MySQL tables that we've loaded into the database.
Thank you very much.